Hi everyone, welcome to Into the Unknown, a talk about Terraform's type system. My name is Patty Carver. I'm the engineering lead for the Terraform plugin SDK team at HashiCorp. I use he, him pronouns, and I'm at Patty Carver on Twitter if you would like to heckle me about this talk. I want to talk today about types. I want to talk today about types specifically in the context of being a Terraform provider developer and trying to understand how these types that I enter in my schema are going to translate into a user experience for a Terraform practitioner. Because I think that's a piece that's missing from our documentation. And as we build out more and more software, as we release things like Terraform Plugin Go, I think it's something that Terraform provider developers are going to be exposed to a little bit more. Helper Schema and Terraform Plugin SDK v2 both try and obscure some of the information about types from Terraform provider developers. It smooths over everything a little bit. As we kind of get new modern Terraform provider development SDKs and tooling available, we're going to expose those a little bit more. And so I want to talk today a little bit about an overview of what Terraform's type system is and some of the concepts and tools that you'll be able to play with soon. Let's start with the old standby, the stuff that you can do in SDK v2. There's strings, numbers, booleans. We're all familiar with them. Fun fact, Helper Schema has the distinction between floats and integers, but Terraform doesn't. Terraform doesn't actually care whether it's a float or an integer or infinity. It's all a number to Terraform. We also have lists and sets, sort of. I'll explain the sort of later. And then we've got maps. Maps are also a sort of. We'll get to that in a second. And that's the stuff we know, but there are some lesser known types. For example, here's an object. An object is a lot like a struct in Go. It's got a set number of attributes, and those attributes have a set type. And the attributes are accessed by using a string name. If you remove an attribute, or if you change the type of an attribute, it's suddenly a different type, just like in Go. Tuples are a lot like objects, but they're a list format. So instead of being accessed by a string name, they're accessed by an integer position. So it still has a set number of attributes or set number of elements in this case. And the elements still have a set type on them. And if you change either of those things, it's not the same type anymore. But now instead of having a string key associated with them, they're just put into a list syntax. Now, remember how I said that lists and sets were only sort of lists and sets? Terraform parses the configuration without any understanding of what types the provider developer has specified for those fields. And so it parses it into the most permissive types that it can. So anything that looks like a map or an object is going to get parsed as an object because every map can be represented inside an object, but not every object can be represented inside a map. Similarly for lists and sets and tuples. So those are sort of sets and lists and maps, but really Terraform understands them as tuples and tuples and objects until it gets the type information back from the provider, and it's like, they expected a list here. I'm going to convert this tuple into a list because all of the elements are the same type. If it can't do that conversion, it throws a syntax error for you. Very helpful. There are also the ability to have maps of not strings. I know that Helper Schema in SDK v2 expects all the values in a map to be a string. That's not actually necessary. They all just need to be the same type. That's all it takes. And so here's a map of numbers. Terraform doesn't really care. You can have a map of list. You can have whatever complex, weird type you want. Doesn't matter. Terraform's just happy. Helper Schema in SDK v2 is where the limitation on using only strings as values for maps comes in right now. And then finally, there's this weird dynamic pseudo-type. It's just one weird type. We're going to talk about that in a minute. We're going to establish some context. We'll come back to it. Stick a pin in it. All this is neat, but why do I care, right? I want to talk about how you're going to see this data. There's going to be a couple new concepts I want to introduce in this talk, and to do that, we need to examine what values these things can hold. Because Terraform sends over whatever's in the config, state, and plan. If you have a field that's a number and the user enters 1, 2, 3, you're going to get 1, 2, 3 in the provider. Usually. There are two edge cases, and those are the concepts I want to talk about today. What if there's nothing in the config? Deezer just doesn't enter a value. It's an optional field, whatever. They just don't put anything in there. what do you get as a provider at that point? What gets sent over the wire to you? Well, you get what we call the null type, or the null value, sorry. You get a null value, and the null value is just, I don't know, there wasn't anything here. It's the absence of a value. And I want to pause before I introduce this next concept. I want to talk about interpolation and the graph. Now, you'll see why. It's going to be important in a minute, but I want to explain why this next concept is necessary. Let's take a look at this Terraform config. It's a simple disk. It's got a name, size, and image, right? And then it's an instance that's using that disk. It's attaching the disk to the instance. So Terraform's going to go out and create the disk, and then it's going to create the instance. And we all kind of are familiar with the syntax. It's a pretty common use case of Terraform. If we apply that, we're going to get this plan. And the idea of the instance is going to be, or the disk is going to be known after apply because it's something that the API generates, sure. And therefore, the disk value for the instance is going to be known after apply as well. What I want to know is what gets sent over the wire in that case. What does Terraform send to the provider for that known after apply value? Because we have, for example, in SDK v2, customized diff. So we get the opportunity to modify the plan before it gets presented to the practitioner. How does Terraform represent those values to us? Well, it's time for us to go, and you can all say it with me, into the unknown. That's what we call an unknown value. That's Terraform going, I don't know. I'll know eventually, probably after apply. I'll get you a value at some point for this. It's an unknown value. And so we're reaching the end of the talk here. I want to talk about dynamic pseudo-type because I promised we would get back to that. We're running out of time. Let's get to it. What is a dynamic pseudo-type? It's an unknown type and an unknown value. That's Terraform saying, look, not only do I not know what value this is, I don't even know what type it's gonna be. Who knows? It could be a list, it could be a string, it could be an object. Who knows? It is the empty interface of Terraform. They take on whatever type the practitioner or provider uses. So if you put one in your schema, for example, you send it back down to Terraform. Remember how I said Terraform parses the config and then converts the types into whatever the schema type is? It can't do that in this case. It's saying, just give me whatever was in the config. I don't care about what type it is. Just give me whatever data they give you. Send it back. Similarly, when you're setting values in state, if you've got a dynamic pseudo-type in the schema, you can set whatever type you like. It can be a string, it can be a number, it can be a Boolean, object, doesn't matter. Terraform doesn't care. However, once written to state, they're not dynamic pseudo-types anymore. Just like when Terraform parses it and compares it to the schema and decides what type it should be, it's not a object or a tuple anymore. Sometimes it's a set or a map. They're not dynamic pseudo-types anymore. They've taken on a type. They've become known. And so you can't change it once it gets written to state. There is an exception to this. Data sources replace their entire state object on every read. And so they get to change what type is in the state on every read. So they can use a dynamic pseudo-type that goes from a string to a Boolean to a number to an object. Doesn't matter. That was a quick introduction to Terraform's type system. I hope it was valuable. Thank you so much, and happy Hashi Talks.